Right, thanks everyone. I'm Martin Costello. I'm a principal engineer at justeattakeaway.com and also a Microsoft MVP in developer technologies. And today I'm going to talk about an intersection of GitHub Actions and how you can use it to solve problems that you may or may not know you already have with your .NET software. .NET, modern .NET, not .NET Framework. I'm not going to go anywhere near that today. This stuff does not work with .NET Framework. So I'm going to touch on the .NET patching and support policy, which is the boring bit, but that justifies the rest. What problem we all have that this is trying to solve, and then the approach I've taken to sort of make that be hopefully a non-problem and just a business as usual thing you have to do month to month. So the .NET patching and support policy. There's a new version of .NET almost every month because they have a regular sequence cadence of like doing patches, and that's also when they do the security patches. You might have heard of Patch Tuesday, Update Tuesday, and that's when Microsoft coordinates all the releases of all their software, Windows, Office, you name it, and they all happen on the second Tuesday of the month. So this month that'll be this time next week. The .NET blog is one of the places where you can find out about this. So every month there's some sort of blog post saying what new versions are available. So at the time I took this screenshot, there was a new version of .NET 7 and a new version of .NET 6. Of course, we've got .NET 8 now as well. And there's also the .NET announcements repository. And on that repository, they also create issues where they announce that the security, well, not just that the security updates, but there's patches available. They put a security tag on them if they've got security vulnerabilities in them, and then there'll be information in the issues about what's in the latest release and any security fixes there might be, so that you can read them and assess whether or not you're actually exposed to the issue that's being fixed in a given release. So say, for example, in 1 month, there might be a vulnerability, something to do with XAML. If you're not doing UI desktop software and it's just web software, then you're probably not actually exposed to that. So it's not necessarily as important that you need to patch it. Freshly updated stat from this weekend. So almost 80%, so 4 out of 5 monthly updates do contain some sort of security fix. As I just said, like, might not necessarily apply to you, but I think it's a lot easier to just go, oh, this is security patches, I should just fix stuff, rather than go, oh, but am I actually vulnerable to this? Because then there's just lots of mental interpolation and trying to work out, is my specific use case in all the apps I use vulnerable to this? Whereas if you just patch everything, it doesn't really matter, you're patched. So out of all of the .NET 6 releases to date, to this month, 21 out of 27 have had some sort of security fix, and all of the .NET 8 releases so far, but there's only been 2, have had security patches, and the security vulnerabilities that get fixed are of different types. So they can be denial of service, security features being bypassed, remote code execution, one of the worst types, or elevation of privilege, and then there's other types like information disclosure and things like that. But it's a different flavor all the time. It's not just always, oh, another bug in XYZ. And the official policy from Microsoft is that if you're using .NET, you need to update it every month to stay in support, because if you are running not the latest version and you think you found a bug and you open an issue, I can guarantee the first thing they'll probably say to you is, are you running the latest version? And then if you're not, they'll go, can you update it and see if it's gone away? And then they'll look into it. So in general, they're not quite as, no, the policy says this, do that, or we won't look at it. But if it starts to get a bit gnarly or they're not sure, then they'll probably just go, well, update it and see if it's fixed. So that creates us with a problem. Every application to stay in support needs updating every month, so you can stay ahead of any bad actors maybe trying to exploit some vulnerability. I'm not aware of any like sort of heartbleed levels of like vulnerabilities that happened in the last few years that like you've had to like patch as soon as possible, otherwise you're going to get pwned. But it's just a good thing to get in the habit of and stay patched and supported. And then as we like to innovate and write new apps, and especially in the era of microservices, you just have more and more applications. You might have dozens at justeattakeaway.com. We have something like 400 individual .NET applications running in our quote-unquote production environment. So that's a lot of stuff to keep patched every month. And we've only got so much time to do things. And if you do want to do it, but you don't automate it, then that's a really drudgy day of the month, even if you can get it done in a day, to spend manually updating all of these things. So that doesn't scale. I can't remember how long it's done this for, but .NET Core does come under the Windows Update umbrella now. But that only applies if you're running on Windows. So if you're on Linux and Mac OS, no Windows Update for you. But also in sort of the cloud infrastructure era, a lot of servers are treated like pigs rather than chickens. So you just scale things up, scale things down, scale things up, scale things down. So Windows Update isn't typically installed on cloud servers, because certainly at Just Eat Takeaway we don't have them turned on, because if we've got an EC2 instance running on a Friday night when everyone wants to order pizza, then we don't really want Windows Update kicking in and interrupting everyone. So it's turned off. So we can't actually rely on Windows Update to do any patching anyway. It's also repetitive, and it's also boring. So it's not so fun. So in the immortal words of Homer Simpson, can't we get someone else to do it? So that's where things I like to do come in. I like to automate things. So the solution I came up with was to marry together some infrastructure that we'll see in a moment with GitHub and GitHub Actions. So we use GitHub Actions and GitHub Enterprise internally, and I also use GitHub Actions for all of my open source repositories, because I like having everything in one place. I don't want to be like, here's my code, right, now I'm going to go over to Team City to do this, and then some other system to do the deployment, and some other system to do something else. I like having it all in one place. It's easier to manage, especially in the open source world where it's just me to deal with this. So we're going to use some open source tools with GitHub Actions workflows to do the patching on some repositories. We're going to use the update .NET SDK GitHub Action, and we're going to use the .NET-outdated global tool. And then we're going to use GitHub Apps to then also automate approving the pull requests and merging them. So on the assumption that you've got a good CI that's going to catch if some horrible, horrible bug comes into a new .NET release that creates you a problem, then all of this will just seamlessly happen in the background, potentially all the way up to production. So actually no humans get involved unless the build breaks. And the advantage with this setup, where you use GitHub Apps and GitHub Actions, you don't need to deploy any code anywhere. So you don't need something listening to like GitHub webhooks to react to pull requests and issues and do things like that. It all gets self-contained inside your GitHub repository. So here's an example of the GitHub Actions workflow that can be configured to do this. So it's configured to run every Tuesday at 9 o'clock in this case. I have yet to find a cron expression that means second Tuesday of the month. So it just runs every Tuesday at 9 p.m. UTC, because that usually means if it's the week that the patches happen, they'll have been released by now, so they'll be available. It's also runnable on demand, which is this workflow dispatch key. And then it uses a GitHub Actions workflow, which is part of the action repository, which I've written, and then apply some labels. You configure it as who to act as. So in this case, it's a GitHub app that's been set up, and that's it. So what's this? I did put the number somewhere. So yeah, 17 lines of YAML, including the white space, to put in a repository to just keep itself up to date. So then we configure some GitHub apps. So there's two apps in this demo configuration. So one is the reviewer and one is the updater. The reason that's there is because you might be using an approval policy with your repositories that someone has to approve something before it can be merged. So like you've got code reviews going on. And if you have that configured, you can't approve your own pull requests because that would be strange. Everyone can approve it, including myself, so I'll just YOLO everything. So that creates like a separation of duties. So you have one bot that raises the changes and another bot that approves them. You could argue that's one person doing everything and wearing a fake mustache, but as far as the approval and workflow policies in GitHub Actions, that works. They also have different secrets, so you'd have to compromise two different things to get the keys to act as both parties. And then for that to work, you just need to give it a few permissions on your repositories, which are, there's one that isn't shown because everything has to have it. It's like a metadata one. So you need to give it read and write access to the contents. So that lets it clone the repository, change the files, push up a new branch, and then read and write access to pull request so it can create a pull request. It works through a pull request model so that if something breaks, there's nothing to roll back. Well, assuming it gets found at the pull request point, there's nothing to roll back. You don't have to worry about automation fighting you trying to roll back your default branch because there's a bad patch come and now it's all broken and you're trying to undo it and then the bot comes, hey, I've got an update for you, and it just ruins everything. It's all done in a pull request. So if it's green, then you can merge it. The only thing you need to act as a bot is there's a private key that you get made available through your GitHub app, and you just put that into GitHub Actions secrets, and then that you can then use other actions which are hidden away in the workflow, in the implementation of the workflow, that exchanges the private key for a bearer token, and then it acts as the GitHub app to do things. So then you just put the secrets into GitHub, into your GitHub repository. If you're using organizations, then you can potentially put these at the organization level, and then it's available to all of your repositories. And similarly, you could configure the workflow in a separate repository and have it act on all of the repositories rather than having to put this in every repository. So here's an example of it running. I would click the link, but I didn't update it, and it's so old now it will have been archived away. But so this is running on a sample repository that there'll be a link to at the end. And so it checks that the secrets are configured, generates a personal access token, checks out the code, runs the GitHub action that does the SDK update. You can then optionally update NuGet packages, and then that's it. Well, as far as that's concerned, at least. And here's an example of something it produces. So we have a pull request. It tells us what version of the .NET SDK it's going to be updated to. It comes from a branch. It's created by our updater bot. And then our reviewer bot comes along, approves the pull request. Our CI runs, it's all green. The reviewer bot also enables auto merge. And then as soon as the build goes green, it just merges. Done. And here's like a view of the diff of what it did. So it changed the global.json to update the SDK, and it updated this version of an entity framework core NuGet package. So for this specific example, that was all that needed updating. So 2 different lines, and that's everything that's needed. So how does this all work under the hood? So first is this .update.NET SDK action, which I wrote. This is on GitHub. And this is the core logic that actually finds out if there's a new release and does the update to the SDK. So within the workflow that I showed in a previous slide, this just has a bunch of parameters so you can customize the behavior. And this is written in JavaScript, so there's no additional dependencies. And the GitHub Actions runners all have Node.js installed on them. So you can just run JavaScript-based actions with no additional dependencies. You don't have to worry about pulling down Docker containers or making sure that other tools are installed. If necessary, it's all just self-contained, which means it's fast. What this does is this checks the .NET release notes. I can't remember, do I have the slide for this? Yes, I do. So if you haven't seen this before, there's a repository called .NET Core. And in that, there's a folder called Release Notes. And then for each major release of .NET, or they kind of call them channels. There's a releases.json file, and in that file, which for .NET 6 at this point is absolutely massive, this contains a huge JSON manifest of all of the releases of .NET. It's got links to all the SDK downloads, what version of runtime it has, what version of ASP.NET Core it has, when it was released, end of life date, lots of data points in it. And this is actually used, this is what drives the .NET website. So if you want to go download the SDK, all the links are actually coming out of this data file ultimately. So if a release isn't in this file, you probably can't download it from the .NET website. But one of the interesting things with this, as well as it can tell us what the latest release is, and then the action can actually go and find the links for that and check the versions, but it also tells us what CVEs are part of a release. So then it's possible to also know if a given release contains security fixes. I don't go the extra mile to try and parse any of that and work out what they are and if they affect you, but it's a really easy to have a binary signal on a pull request, which is this fixes security stuff. Maybe it's a bit more urgent than it's got some fixes. Oh yeah, I already mentioned that. Yeah, that powers the download website. So the next part of the workflow uses a tool called dotnet-outdated. I meant to put a link to this in here and I forgot. Scott Hanselman did a video about this last week. It's about 10 minutes long. It's like a good intro to like how you can use it in different situations. But in this case, I use this to be able to do the NuGet updating automation as part of the workflow, because why reinvent doing NuGet updates when I can just use a tool to do it? So the workflow, after it updates the SDK, then runs .NET-outdated on your solution, and then it can update your NuGet packages, and then it applies some command line parameters on it so that if you're still running .NET 6, it doesn't update all the NuGet packages to .NET 8. It keeps them locked onto version 6 so that you're just getting patch updates. So what this process doesn't do is it doesn't upgrade you across major versions. There's other tooling that does that I might have written, but that's not in the subject of this talk. But here's a screenshot from .NET-outdated, and this is like if you run it manually. So if you just type .NET-outdated after you've installed the tool, it will show you what versions of NuGet packages you might not have the latest version of. And it's not all shown here, but it's color-coded as well. So these are just patch versions, so they're green, it's minor, it's yellow, it's major, it's red. So by using this tool, I can then leverage other people's hard open source work and update the NuGet packages without me having to get into the nitty-gritty of learning and understanding how to do that. The only disadvantage of that is because that's not running under the Node.js stuff, because I want to keep that self-contained and dependency-free as much as possible, it does mean that the pull requests, you get two commits. So it opens a pull request, and then about a minute later, you'll get another commit in the same pull request that updates the NuGet packages. So if you're blessed with an incredibly fast CI system, it might merge it before it's finished. But I've never actually seen that happen in practice. Sorry. I was like, why is the screenshot the same? No, it's not, it's different. So there's an example here, like I've added some extra flags. So upgrade, version lock, major, include ASP.NET Core. So that's now filtered that down to just one package, because what I don't want the automation to do is it shouldn't be updating any and all NuGet packages you have. So in the previous screenshot, we had shouldly, which is a testing library. Don't want to be updating unrelated to the patching process NuGet packages, because who knows what other things that might introduce into it. We're trying to keep it scoped down. So it's just, in this screenshot example, it's just including the ASP.NET Core libraries. And then because I've specified the -- upgrade flag, it's actually applied the changes. So then if we look at the diff, it's come along and it's changed one line and updated the package for us. And then if you run it again, if you still didn't believe it after it's done that, it doesn't find anything because everything's now up to date. So that's run inside the workflow. And what the workflow does is you can give it a list of NuGet packages to consider to upgrade That's a parameter in the workflow you can change. By default, it updates Microsoft.ASP.NET Core, Microsoft.Entity Framework, System Text JSON, and Microsoft.Extensions libraries. Anything else isn't considered, but if you wanted to, you could change it to just update everything if you wanted to do that. Personally, I prefer to use Dependabot to do that because I get a change per thing. So if there's a bad change, I can merge all the others and leave one alone rather than it all being bundled together in one big blob, and then I have to unpick it if somehow, for some reason, it's broken. So it goes through and it includes the packages that we want to update and then updates them. And then we configure .NET-outdated. It can output as a JSON file what it did. So then I can parse the JSON file and pick out what's actually been updated, which comes in use for this step. So I mentioned Dependabot. If you've not used Dependabot, it's doing a similar thing to .NET-outdated. It updates NuGet packages as well as NPM packages, Python modules, Docker images, Ruby gems, loads of stuff. If it's a dependency ecosystem, Dependabot can probably update it for you. And one thing that Dependabot does is it puts, I can't remember what the exact term for it, I want to say front matter, but I don't think that's right. It puts a little bit of YAML in the commit messages that then means it's easy to machine read what it did on the assumption that what it said it did is what it actually did. So I replicate this approach with the commit messages for the SDK updates and the NuGet package updates. So the important bit is this here, the -- updated dependencies bit. So that means that later can programmatically inspect what was changed rather than trying to parse the diff or trying to do a git diff between things. We can just read the commit message and see what happened. So example of that from it shouldly, it doesn't really matter. But so here's what Dependabot did. So it gives you loads of links to what patch, release note, commits and stuff. And then that's what it actually did here. So it updated a dependency as a patch of the dependency shouldly. So replicating that with our example pull request. So this updated 2 packages from 7 to 705. And then we've got the names of the packages as 2 items in an array in YAML in the commit message. So that means this is where our approver bot comes in. So now when a pull request is opened, we can create a workflow that looks at the commits from the pull request and works out what happened. So in this approval workflow, what we do is we only look for pull requests that come from the GitHub app that we've set up to create the pull requests. So it doesn't interfere with any pull requests that the humans in your team might open. So it's not going to start piping up auto-approving people adding new feature work to an application. Keeps out of the way, as long as you keep the roles separate. If you run it as yourself, then all bets are off. So then that will then look at the commit messages and see what you actually did in the pull request, or not you, the automation, because then it can inspect it to see what was actually changed, so it can make a decision on whether it actually wants to approve the pull request or not. So workflow runs, checks what's happening, and the approval workflow is relatively simple. So it uses the GitHub CLI, which is this GH tool. It's quite handy, it's quite scriptable. So what this does is this gets the pull request commits, and then the GitHub CLI also has JQ built into it, so you can give it queries to parse the responses that come from the GitHub API to just pull out the bits that you care about. So in this case, I'm just pulling out all of the commits, and for each one I want the author and the message. And then I loop through the commits and check whether they match a regex, which is looking for that YAML bit of information in the commits. From that, it pulls out all the names of the dependencies. And then as an additional check and balance, this workflow is configured with a list of NuGet packages it expects might be updated. And then it checks that not only are all the packages that were updated ones it thinks could be updated, but also that they're all patches. So if something goes wrong and it does a major version upgrade for some reason, then it won't approve that either. And that's that slide. And then if it's happy that everything that was changed meets the requirements of what it thinks should be changing, then it uses the GitHub CLI again, and it approves the pull request. And then that's the next slide. So it approves the pull request, and then it enables auto merge, which is a great feature of GitHub because it means, if you're a human at least, you're not sitting there staring at the green spinny wheel, waiting for everything, all your required statuses to be green, so you can then press the merge button. You can just say merge it if it passes and go away and do something more important, you know, like wheel around on your chair, or lightsabers. XKCD's got to come up with some new use cases to get over the old compiling excuse. Yes. And then, so you might go, oh, is this just going to rubber stamp everything? So we've already had the, like, it's got the filtering. It's not just going, did a pull request get opened by this bot? Yes, rubber stamp it. It's also like looking at what it did. And it also checks as new commits come in. So if I come along to one of these automated pull requests, and I do it quickly enough that it doesn't get merged before I do it, and change anything else, it will just unapprove its own pull request and go, you changed something else, I don't know how to review this anymore, so it's your problem. So if you're operating in a very compliance-y arena with your code, maybe it's for PCI reasons or something like that, then this should help alleviate any questions auditors might have. It's like, oh, does this mean you can just shove any old change into the robots change and then deploy stuff without any human review? The way this is set up, no, because it will unapprove it. Of course, there's a bit of a lag between you doing something and it noticing it and doing something, so it's not 100% bulletproof. You could swoop in at the last second, but that's the sort of the compromises to use the automation here. It's like if you've got super mega critical approval stuff, might not work for you. You can still do the updates, but maybe not the automated approvals. So to get all of that working, we created 2 GitHub apps, one to do the updates, one to do reviewer. So that's effectively our service account. So it's not running as us, it's running as some automation. And then there's 2 workflow files that we add into our repository, one that does the update, one that does the approvals, and then we just wait until Patch Tuesday for something to happen, and then it will all kick in, and we'll all be happy and not have to manually do this patching ourselves. So there's some links to the sample code here. There's a GitHub repository I've set up, which has all of this stuff installed into it. So every month it just pops up and updates itself. It doesn't really do anything on top of that, but it's not just a stupid app that does nothing. It's your typical to-do app example. It's got some UI tests, it's got some integration tests, it's got some unit tests, because ultimately this is the most successful when you actually have tests that's validating your application works whenever a change is made to it. If you don't have a CI set up, then it's removing the element of you doing the manual updates, but it's not removing the, oh, but now I have to test it. Whereas if you have the tests, then you can pretty much hands off the entire thing. I think of the entire time I've been using this, because I put this on all my open source repositories, it updates everything for me. I think there's been 1 month where the .NET release itself has had a bug in it that's meant I couldn't apply it, but it broke my CI. So I just opened an issue and I was like, hey folks, you broke it? And they were like, oh yeah, we did. It wasn't like a huge kaboom, the whole thing's broken bug, but for what this, not this repo, what the repo that found the problem happened to do, it just broke things and I couldn't use it. So I just had to leave the pull request open, wait for the next month for them to fix it. Or if memory serves, they'd said, no, here's a workaround, and I just applied the workaround. And the sample code uses the action there's a link to there. And then the action has a workflow in it that adds on the NuGet capability with dotnet-outdated, which is a great tool. It's got lots of other uses. So I also recommend that even if you don't use the automated workflow. And if there's something, if you try it out and it's missing something that you might want to use, I'm always happy to accept pull requests or issues with suggestions on things to change with it, as long as they're general utility. If you've got some no judgment, if you've got some custom bespoke internal thing and it doesn't work with that, if it's not as open standard sort of thing, I'm probably not going to take that change. But otherwise, happy to take pull requests on updating stuff. The ASP.NET Core team themselves actually use this action now. They do it to update their .NET SDK that they update once a week as part of the upcoming previews. First time they used it, didn't quite work because they had one extra bit that I had never used before, so I had to do a PR to fix that. But otherwise, it's like, works for them. Take that as an endorsement if you like. And that's it. Thank you for having me and paying attention and listening to what I have to say. If you want the links to all the repositories and what have you, everyone's favorite QR code. That leads to a GitHub repository that's got this slide deck in it, and then the links are in there. And that's it, unless there's questions.